Hello everyone, I hope you all are doing well and that specifically you will enjoy this talk, where I'm gonna present MOCHA, which includes new methodologies for anonymity quantification in mixed network. To make sure we all are on the same page, I will start my talk with a brief introduction to anonymous communication system and necessity of having them on internet. Later on, I will bring up issues with the current anonymity quantification in mixed network as a type of anonymous communication system, and subsequently to address those issues, I will introduce MOCHA's methodology. And lastly, I will bring up briefly MOCHA's key result to conclude the talk. Okay, so as you might know, by default on internet, when two endpoints want to communicate, their communication will be protected or secured using cryptographic operation like end-to-end encryption. However, the fact that these two endpoints are communicating will not be protected or hidden from the perspective of a network adversary observing this communication. And this actually can create some privacy issues. To address these issues, one of the typical choice for a client is to use Tor network. So actually, Tor network is an overlay network on internet which consists of many nodes that are known as Tor relays and usually are categorized as exit, middle, and guard relay. In Tor, when a client wants to establish an anonymous communication path to a destination, she will require to pick one exit, one middle, and one guard relay. And then she will participate in some key exchange algorithm with these relays. And in the end, once she wants to forward her packets or messages to this Tor network, she will start encrypting them with the key that has been exchanged with exit, with middle, and with guard relay respectively. And in such scenario, each intermediary relay, after receiving the packets from the preceding relay, will peel off one layer of encryption and forward the packets or messages to the succeeding relay. Tor network in such setting will provide anonymity for the client to the destination connection. However, this anonymity will be provided under two critical assumptions. The first assumption is that this guard relay and exit relay are not owned by the same entity. And the second assumption is that the internet service provider who observes the communication from the client to the guard relay is not as the same as one who owns the network from the exit relay to the destination. As you might guess, if the latter is the case, unfortunately the client destination connection can be compromised. To be more specific, in such case, the internet service provider can actually gather information about the packets entering the Tor network and the packets exiting from Tor network. And later, he can take advantage of neural network techniques to correlate who communicates with whom, which unfortunately has been shown with high accuracy can happen. So the anonymity will be compromised, and it's so sad. In order to mitigate such adversarial behavior, first, we need to have a good understanding of mixnode. Mixnode actually is an entity on internet which receives traffic from different sources or clients and will shuffle or delay those traffic and afterward will flush them out. So if you consider this scenario from the perspective of network adversary, it would be kind of impossible to map the input traffic to the output. So kind of this entity will help us to mitigate the adversarial behavior. To be more specific, usually we use mixnode together with others in a network shape that we call it mixed network or mixnet. Mixnets are usually formed in layer format, where each mixnode can be part of only one layer. In mixed network, client similarly will select one node from each layer to make a communication path for a specific packet to the destination. In mixed network now, the internet service provider can observe or corrupt all parts of the internet, and still he cannot figure out who communicates with whom. We can go to the extreme with that. We can consider even this internet service provider offering some mixing process by corrupting some mixed node in mixed network. Even in such case, as long as one mixed node along the client to the destination path is trustworthy, the client to the destination connection will be privatized or let's say anonymized. So that's perfect. We had an anonymity issue, and using mixed network, we are able to perfectly address this. That being said, it's very important to be careful in a way that we quantify this anonymity. For instance, in prior works, usually it will be imagined that there is this global network adversary, or you can think of as the internet service provider who observes all the links on internet, and they assume that potentially this guy can at some point target some messages that are entering mixed network. And then this adversary will take into account two facts about the randomness that will perturb the communication patterns in mixed network. He knows that the first source is the mixing process that will be imposed by each mix node to perturb the input and output traffic, and the second source of randomness is based on the message distribution from one layer to another. Considering these two sources of randomness, then the adversary will wait for the messages to be transferred through the mixed network. And in the end, the adversary might consider all messages that are coming out of the mixnet and will specifically think that with what probabilities each specific message could be the initially targeted message. And then he will come up with a probability distribution that, for example, in this figure, out of these three messages, the first two can be targeted message with probability of 50%. And the entropy of that distribution has been suggested by prior works to be the anonymity metric. And then they have suggested that one can repeat this scenario for many cases for longer time to, for example, in the end, on average, conclude that, for example, under such setting, this mixed network provides, let's say, 8 bits of anonymity. However, in MOCHA, we realized that this kind of quantification can be really exaggerated. For instance, you can consider this counterexample that we have only one client sending all messages through the mixed network. In such case, the global network adversary will have no problem to distinguish which message is generated by whom. Basically, with probability of 1, each outgoing messages can be mapped to the input messages. So basically, we have naturally no anonymity in this case. However, we realize that if you use message anonymity metric, it will show you some number. So that means that message anonymity will exaggerate about the anonymity that has been provided by mixed network. To resolve this issue, MOCHA suggested using client anonymity instead. So we again consider this global network adversary who corrupts all parts of the mixnets, or let's say not mixnet, but on internet, all the connection will be corrupted by this adversary. And specifically, this adversary considers the source of randomness that are coming from each mixed node, and also for message distribution from one layer to another for message traffic perturbation. And in the end, this adversary is interested to figure out with what probability each outgoing message can be mapped to any of the client generating and forwarding messages to the mixed network. For instance, in this example, the adversary can target this message and think that, okay, there are 4 clients forwarding messages to the mixed network. 3 of them generate only 1 message and another 2 messages. So this can be the empirical distribution of this message being generated by any of these clients. And in the end, this probability distribution will be considered and its entropy will be computed. For instance, in this case, the entropy is 1.9 bits. And this can be a notion of anonymity in MOCHA. And to basically make some comparison with message anonymity, in MOCHA we perform many experiments, but here I will show one of the key experiments to see that how misleading the message anonymity metric can be. To this end, we considered 2 settings. The first setting is where there is only one mixed node where client tries to, forward their messages to with the hope of having anonymous communication. And another setting is a mixed network where we have 3 layers of mixed nodes. And each message actually will go through 3 mixed nodes. So in this case, we also try to, change the number of clients from 10 to 130 and measure both message and client anonymity. As you can see in this figure, when we increase the number of clients, the message anonymity will not change. And this is really surprising because naturally the higher number of clients, the higher anonymity in mixed network. On the other hand, if we use client anonymity metric, this actually anonymity will change rapidly and shows, for example, up to 2 or 3 bits the anonymity can change when you have 10 compared to 130 clients. On the other hand, we realize that message anonymity recommends us to increase the number of hubs in mixed network. For instance, when we increase the number of hubs from 1 to 3, the message anonymity considerably will increase. However, we see that the client anonymity will not increase that much. Will slightly increase if you increase the number of nodes from 1 to 3, but it's not dramatic. So that brings us to this conclusion that unfortunately message anonymity might provide some exaggerated result or misleading result that are not real and can be very detrimental once one wants to use this message anonymity to tune mixed network actually parameter. So in a nutshell, in this talk, we learned that on Internet, we have anonymity issues considering the identity of endpoints. One can resolve this issue using Tor network, but unfortunately Tor is very vulnerable to the adversaries observing both ends of the network. To have higher anonymity, you can definitely use mixed network, but mixed network usually has been considered to be quantified by their anonymity using message anonymity metric, which is not super accurate and might lead you to have some misleading results. To have better understanding of the anonymity that mixed network can provide, we really suggest in MOCHA to use client anonymity that hopefully can provide better picture of anonymous communications happening through mixed network. Yeah, so that's all I wanted to talk about. Thank you so much for listening to my talk. You can find the slides of this talk together with the paper itself and other related paper and blog posts on my webpage. And if you are interested in anonymous communication or this type of research, please feel free to stay in touch with me through LinkedIn. Thank you so much.